Science Beetle.
Hey, welcome back, students. In this video, I want to go ahead and address two main principles of science that has a lot to do with the measurements that we take in class and in the field. And that is the issue of accuracy. And so let me just write these down. So we got accuracy, and on the other hand, we've got precision. Okay, so let's kind of separate these out and ask ourselves, what's the main difference between these? Now, these two words are very different, and at the same time, they're very much the same. So the way these words are the same is that they both refer to a very specific thing. They're actually both referring to how close we are to a given measurement. So both accuracy and precision, they both address how close you are to the what we call the true value or the real value on a measurement. So that's what we're talking about here, on a measurement. And so when we talk about this, it's really important that we distinguish them from each other. Now, accuracy is very different than precision. Accuracy is dealing with only one attempt. And so this is going to be on a single attempt. And that's when we refer to accuracy. Another way of saying this is it's how close you are to the real value on a single trial. So I'm going to put slash and I'm going to put trial here. Now, when it comes to precision is slightly different. Precision actually is going to be dealing with how close you are to the real value on multiple attempts or trials. Okay, so what does that look like? All right, so I've redrawn it here. And so let's address accuracy first. So when we have accuracy, what we need to point out is kind of what these stages are. So if you're familiar with the dartboard game, typically you shoot at a center object here. This center object here identifies what is the true value or the actual value. Now I'm using the representation of darts because it's a lot easier for us to visualize this. So if I kind of put myself, put a little dart here, here's my little figure of a dart. And what I'm going to do with this dart is I'm going to actually shoot the dart. And it's going to come in. So I really want to hit this mark here at the center. Now, if I shoot the dart, and let's say that the dart lands there, then we can say now that the difference here between this dart is going to be something like this. Like if we were to come in here and look at the distance from the center to the tip where this arrow hit, that's actually going to have a very specific distance. The greater the distance from the actual value is essentially our error, or how inaccurate we were. Or if we want to look at it from a slightly different perspective on the same topic, is how close were you? So your accuracy then could be described as being low accuracy. Now, if we actually move this and got it a little bit closer, then we would say that our accuracy is actually higher. Okay, so let's pretend that we make the shot. And let me represent the shots this time with X's. And so let's say that I shot here X, and I shot another one, and that was right there. Let's label these for the sake of argument. Let's call the first shot, let's say we're going to call this shot number 1. The second one was shot number 2. Now, if we do it like this, we can make a comparison between the shots and say individually, shot number 2, because it is closer to the true value, shot number 2 is more accurate than shot number 1, because look at the distance, it's a little bit bigger for shot number 1. When we look here from the center to the center and from the center to the center there in comparison. Now, if you want to, what you can do is you can actually represent this, and let me zoom in a little bit here. And so what we can do is we can see a little bit here, the distance from this point here is actually a little bit smaller than the distance over here. And you can see that already. Now, because of that, we would then say that, again, 2, the second shot, was actually more accurate when compared to the first shot, because what we're doing here is we're making a comparison between individual shots. Now, if we actually group this together, and we look at this, we're going to say one important thing. We're going to see here that if we start adding more shots to the mix, and let's say that we have a couple more, and I'm going to go ahead and put this as, say I have another shot here, and let's say I'm going to have another shot here, and just for the sake of argument, let's say I've got the shot there, and let's give them all shots. Say this is shot 3, shot 4, shot 5. Now, as a collection of shots here, I've got 5 attempts. Now, one thing that you can do, a couple of other shots in a different color, and then we can make a comparison. So let me go ahead and do that now. And so I'm going to put these shots here. Let's say that I have this one shot over here. I have a shot here. I have a shot here. I have a shot here. And I'm going to say a shot right there. And let's go ahead and label these as well. Let's label them respectively here 1, 2, 3, 4, and 5. Now if we put that lasso around the shots that we started off with in red, we will have this. And so let me just put that right here. We'll come up here, we'll come here, and there's the grouping for these. If we do a similar thing here and start grouping the others, let's see if we can use a slightly different color here. And come around, and you can see now that if we compare the area occupied by the first shot, notice the area in green is significantly larger than the area in yellow that was part of the purple set of shots. And so when we're looking at this, we can actually make comparisons between collections or trials, and we would say that because of the greater area for the shots in red, we can see here shaded in green that this actually is more spread out. There's more variability, and we would say that this particular group, the group in red, identified by the green area, this actually has less precision because those shots as a group are more spread out than the other shots. And so we look at the other shots here in purple, represented by the shaded yellow area, we can see here that these shots are actually grouped closer together. So they would be more precise in a sense because they are actually, on average, if we were to come in here and measure the actual distance between them, between here and here, say the center and point 4, the center and point 3, you'd see that those measurements would actually be smaller. So the average, if we would actually do this and measure it out, that the distance between the center points of each of these points in purple to the center is actually slower than the center point from the points in red to the center. And so one way of representing that mathematically is essentially writing a formula something like this. And let me zoom out on this. And so let me put this up here. And what I'm saying is that if I were to take the representations of the points in red, so let's say that way I took the sum. So if I took the distance of the point, let's say just called here point 1 to the center, and then I took the same thing for point 2, and the same thing for point 3, and the same thing for point 4 and point 5. And I took that amount and then I divided it by 5. That's actually going to give me the average distance. We represent that average with an X with a bar over it. And we can call this is going to be the average for the red. We can do the same thing here for the purple and make those changes. And so let me see if I can move these over here to the side. We can bring that up there. And if I repeat the same process here for the purple, so here we would have the distance for point 1 in purple, point 2, point 3, point 3, point 4, and point 5. If I take the distance from the center of those points to the center of the target and divide that by 5, that will give me an average of the purple measurements. And what we'll see here, we compare these, we're going to find that these particular measurements are going to be slightly different, and we're actually going to wind up getting a better measurement average for the ones in purple. And so that's really what we're trying to say here, and because we're comparing them as a group, we can use the word precision. So on average, the points in purple are going to be more precise as a group because they're closer together to one another. And in this particular example, the average is actually closer to the true value. So we would say that the measurements in purple would have a higher degree of precision. Now, we can come in here and look at individual records and we can compare them, but when we're comparing individually, those comparisons are going to be more aptly referred to with the word accuracy. And so this here is the main difference between accuracy and precision. Now, when we look at measurements overall, we want to make sure that we are engaging in accurate measurements so that collectively, if we do trials of measurements in any experiments, our precision is higher to the true value, and that should reduce our overall error. So with that, if you haven't already done so, go ahead and subscribe, keep watching, keep learning, and we'll see you in the next video.